All right. Last section of chapter 6. All right. So we're going to have a quiz next week. This, just to be honest, this section takes several days. All right. The quiz would probably be mid to late next week, like right before break. So it's going to be 6-1, 6-2, 6-4. Just for your own good, I think some of you are still struggling with U substitution. All right. There's a bunch of resources out there. We have to move on. We spent several days on it. I did all I could do. I mean, there's not a whole lot more I could do to say, no, there's some magic formula. Here's how you do it. Like, no, everyone's different. You have to know the rules to recognize the substitution and then how to actually do the antiderivative, right? And by grading those quizzes, like some of you are still struggling when to make an exponent negative, when it's ln, even though we played that fun game. All right, I'm gonna go so far. So we'll take a look at those, but really make sure you're okay with that moving forward. Today, we'll just touch on exponential growth and decay and separable differential equations. So what is a separable differential equation? Well, it's of the form f of y times g of x. F of y times g of x. It's called separable because you can algebraically separate them with y's with the dy and x's with the dx's. Do you agree if I divide by f of y and I multiply by dx, I can get the x terms with the x terms and the y terms with the y terms? And then integrating both sides with respect to their thusly isolated variable. Ooh, there's a word for you. Thusly. These are very often paired with a slope field. Remember those slope field problems in the book, how some of them had x's and y's in them? dy dx equals x squared times y, something like that, right? Now, if it's x squared plus y, it's not separable. Separable, the x's and the y's have to be multiplied. That would not be separable, but a lot of times you'll see these separable differential equations with a slope field. For your response, they'll ask you part A, graph the slope field. Part B, they'll ask some random question about the problem. Part C, find the particular solution to the separable differential equation below. Word for word. And you'll get one of these. All right? I have good news for you. We have all the tools necessary to do these problems. It's not a whole lot that's new. All right, you ready? Did you guys get everything down? Not yet. All right. All right. dy dx equals x squared, y equals 3 when x is 0. We're going to hold off on the slope field for now. Let's go ahead and solve this separable differential equation. And I'm going to give you steps to solve these every single time. So if you're one of my step people, step 1, separate the variables. All that means is get the x terms with the x terms and the y terms with the y terms. I bet you would agree we need to divide y squared and multiply by dx. So we're going to get 1 over y squared dy equals x squared dx. Everybody okay? That's just algebra. Divided the y squared over, multiply the dx. And I can't tell you how many times people miss these because of that algebra step. And then you're toast. Like, honestly, these are like 6 points on a free response. This part of it is like 5 or 6 points. out of the 9 on that free response. And you'll miss most of the points if you don't separate it. Okay. All right. Step 2. Well, wait a minute. What are we doing here? They asked us to solve for y. That should be shouting to you, take the antiderivative, right? Isn't this dy dx? Now, we've never seen one like this before, but trust, if this is dy dx, then the antiderivative would be y, wouldn't it? So, antiderivative on both sides. We have to do it on both sides, obviously, to keep things balanced. So if I take the antiderivative of the left side, I have to take the antiderivative of the right side. Now, when I told you there's not a whole lot new in this section, this is what I mean. If I gave you this over here as a standalone problem, could you do it? To ln or not to ln? Not to ln. You would raise y to the -2 power. That's just a rewrite. And then you use the antiderivative power rule, right? Now, here's the deal. Watch up here. You have to, there's an equal sign. You have to keep things equal. If I choose to rewrite the problem on the left side, I'm not going to take the antiderivative on the right side. Do you see what I'm saying? Okay. It'd be like saying x squared equals 16. And I take the square to one side, but I don't take the square to the other, right? Like, keep things equal. So if I took a step, an algebraic step, I better just rewrite the right side. And now we're ready to anti-differentiate. So this becomes y to the -1 over -1. So really it's -1 over y. Y to the -1 over -1. Y to the -1 over -1. Just bring the negative out front. Plus c equals 1/3 x cubed plus c. Now, what are we trying to solve for? Solve for y. How can we solve for y? Well, get y by itself, but don't we need to know what c is? And we can find c because we were told a point, x equals 0, y equals 3. Now, wait a minute. Let's pause on that for just a second. Here's what I'm going to allow you to do. 1, you cannot cross out the c's. Do they cancel? No. But they're both c. They could be different c's. Like, you don't know that the constant of integration on this side is the same as the constant of integration on that side, do you? No, we don't know what c is, do we? Okay, so maybe we should be a little more specific and call this one C1 and this one C2. What are we trying to get by itself? Y. So this would be okay. What's C2 minus C1? Some constant. That could be different, right? I mean, it's some constant. Just call it plus C. You don't have C2 minus, you don't have to write C2 minus C1. It's just another constant. Are you with me? So what am I going to allow you to do? I'm going to allow you to go straight from here to here, where you just write the one, just write the c on the side with the x, because you're trying to get y by itself, right? Just write the c on the side with the x. I'm okay with that, as long as you understand why that's allowed. Okay? And this is that moment where I told you, if you don't write the plus c, you are going to lose a lot of points. Okay? Because this is where it'll all fall apart. So anti-differentiate both sides. I'll even write to protect you. Don't forget to drink your Ovaltine. No, that's something different. Don't forget the plus c on the x side. Anybody get that reference? Don't forget to drink your Ovaltine. Yeah. Christmas story. Plus c. All right. And then 3. Now, this is where I disagree. Like, I differ from some other mathematicians. The AP, when we go to score these and look at the rubric, they leave the plus c in it. They'll solve for y with the plus c in it. I think that's dangerous. All right. I tell you to solve for c at this step, because I think you guys are a lot more comfortable working with that plus 5 or minus 2 if it's a number than some generic c. Because what if you have to what if you multiply by y on both sides right now? You'll get 1/3 y times x cubed plus c times y. Like, what do I do with that, right? You get what I'm saying? And there's going to be some ugly functions that we're going to be dealing with. So I recommend getting it as a number now. So we're plugging in 0 for x and 3 for y. 0 for x, 3 for y. So we get negative 1/3 equals c. So c is negative 1/3. Step 4, plug c in, then solve for y. So negative 1 over y equals 1/3 x cubed minus 1/3. From here on out, it's just algebra, right? Go for it. Solve for y. A little practice. A little algebra practice. Did you get negative 3 over x cubed minus 1? I could have messed up. You guys get some stuff with a lot of 1/3s in it? All right, what'd you get? We can make it look like this. It's just a beautification project. Oh, geez, you guys are so nervous about your algebra. Are you being a little algebra sensitive here? Did you do this? Nobody distributed the y, did they? Okay, thank you. All right, did you get y equals -1 over 1/3 x cubed minus 1/3? Okay, I guess that's okay. Do you agree you could have factored a 1/3 out the denominator and then keep change flip to the 3 to the top? Yes?
Yeah, that's fine.
You want to see it? Keep change flip. Okay. Guess what that is? That is the solution to the separable differential equation. Do you remember writing down the words particular solution and initial condition? Remember those? Let's practice. What was our initial condition on this problem? 0, 3. Initial condition. Okay. What is our particular solution? Well, it's what's in here in red. That's the particular solution. If I took the derivative of this thing, what would I get? X squared, y squared. Do you believe me? Do you believe me?
Yeah.
Lane doesn't believe me. You little twerp. I've gone off on a few kids today. I'm not afraid to go off on more. You want to go? I got so angry second period.
Story time. Recording. You're learning.
We'll be right back. So that's how you solve a separable differential equation. All right, on to the slope field. All right, just plug in points. Now, graph the easy ones first. When x is 0, slopes will be 0. When y is 0, slopes are 0. Let's go 1, 1. 1, 2, 4. Okay. 1, -2, 4. 2, -2.
That's -1 part. That's 1 -1.
Oh, thank you. 1, -1 should be 1. Okay. All right, and then 1, -2. What would we say? Let's just do a couple more. 2, 2. 16. I mean, just go like Steve, okay? And good. I mean, is that enough for you guys?
Yeah.
All right. Again, like I told you before, here's a scoring rubric on this is a released 2005 free response question. 1 point for 0 slopes and 1 point for non-zero slopes. Awesome. So here's the layout. On the axes provided, sketch a slope field for the differential equation. All right. Then they ask about a tangent line. Find the particular solution to the given differential equation with initial condition. Remember how I told you you're going to see these words. You're going to see them word for word. Yes? Wendy, if you don't stop, I'm throwing that watch out the window.
You want that?
Had enough of the token this week. All right. Make sense? Anyway. All right. I'm actually going to have you guys. This will be our next problem. Go ahead and solve this one. Parts. Actually, yeah. You guys can do all 3 parts, A, B, and C. This will be. We'll finish up class with this one. We'll check it in about 10 minutes. You guys have 10 minutes On a typical free response, you're going to have 15 minutes per question. All right, let's check. Let's check as much as we can on this problem. Slope field, letter A. There's your answer key. 2 points out of 9 if you got the slope field. Yes? Part B. Did you guys remember linear approximation? Some of you are like, math was made to be forgotten. All right. I bet you heard my voice saying the 2 things you need to write the equation of a tangent line. Did you hear my voice? Oh, how sweet. All right, so a point and a slope. Well, guess what? Isn't dy dx going to be your slope? So plug in x. What's our point here? F of 1 equals -1. So 1, -1. 2 over -1, -2 times negative is +2 for the slope. Is that what you got? Part B. Y minus y1 equals, did I say 2 or -2? 2 times x minus x1. And the point was 1, -1. So it's going to be y plus 1 equals 2 times x minus, bless you. Do you agree that's the tangent line? Don't do much with it. Just leave like that. That is a perfect answer for full points. Now, what about the use it to approximate f of 1.1? Oh, yeah, I remember this. Linear approximation. Section, I don't remember. No, 4 or 5. So linear approximation was L of 1.1 is approximately f of 1.1. But wait a minute. I don't know what the f of x function is. I don't know how to plug in 1.1 into f, or maybe it's pretty difficult to plug it into f. It's okay. I'm going to use the line. Here's a quick little reminder. Crazy function. 1, -1. Missed it. 1, -1. Ready, class? F of 1 is -1. Do you remember how we called this line L of x? Yes? What's L of 1? L of 1. It's -1. Because guess what? That's the tangent line, and it has to touch the function at the same point, yes? But wait, there's more. If you buy right now, no. It sounds like an infomercial. If I plug in, if I want f of 1.1, I can't do it. I can't plug in f of 1.1. Can I, Adam? No. So guess what I have to do? Plug 1.1 into the tangent line and say, oh, that's pretty close. It's pretty close. So isn't L of 1.1 telling me to plug in 1.1 in for x and to call this the L of x line? Yes? So L of x plus 1 equals 2 times, what's 1.1 minus 1? 0.1. What's 2 times 0.1? 0.2 minus 1. negative 0.8. What does that mean? At 1.1, the function and the line are pretty close. And I'm going to approximate the blue dot with a red dot. And that red dot is at a height of negative 0.8. Now listen, use common sense here. Look up here for a second. What kind of slope did I have? What did the red line's slope? What was it at 1, negative 1? The slope was 2. So imagine, look up here. I have a point 1, negative 1, and I have a slope of 2. Doesn't that mean the function is going up at that local interval, right? So if I was at negative 1 and I'm going up, it makes sense that negative 0.8 is going to be a good value. It's a little bit more than negative 1 because I was going up. Make sense? And I'm staying close. I stayed really close to the x value. Linear approximation. If you don't remember it, put a star by it. Say look up section 4.5. All right? There's a wonderful video on this, okay? Somewhere, I don't know. Not on my Canvas page, but no, I don't know. If you want to watch it, you're welcome to. Some may call it bonus content. I don't know. Whatever. C, find the particular solution. This is where most of your points are going to be, just out of curiosity. I'm going to see how many points out of 9 they put it for this question. It was 5. 5 out of 9. 5 out of 9. That's almost 5/9, okay? Math joke. All right. Did you get negative square root of 3 minus 2x squared?
I got the one above that.
Y squared equals negative 2x squared plus 3?
Yeah.
Okay, but they ask you to solve for y.
I did the square root of that. I just didn't do the negative up front.
Okay, so how many of you got this far? Raise your hands. All right, so we need to go back a little bit. All right, did everybody separate the variables?
Yeah.
Okay, look, you need, listen, I know it's a Friday, okay? I know whatever your excuse is. Pay attention, all right? These are huge point values on the AP test. I'm going to walk you through it. You need to see the rubric so you know when you're on the test, taking it yourself, you're thinking in your mind, this part's going to be about 5 points. Here are my checkpoints I need to do. Ready? Step 1, separate the variables. Did you separate y with dy and x with dx? You just got a point. Did you take the antiderivative? Did you put the plus c on the right side? Awesome. You just got 2 points. What do you notice? Oh, these are a lot like Mr. Westfall's steps to solve these problems, aren't they? Did you remember the plus c, and did you solve for c and get 3 halves? You just got a point. Now, when it says uses initial condition, I honestly don't know how they. Well, I guess the constant of integration. Did you remember the plus c? That's a point. And then did you use the point 1, negative 1 in it to find c? I guess that's the second point. Okay. Last point is to solve for y. So here we go. Once you plug in 3 halves, you get y squared equals negative 2x squared plus 3. Oh, they multiplied by 2 already. Okay. So did you get something other than 3 halves? Did anybody get something different than 3 halves? That's okay if you did. It depends on where you solve for c, okay? If you plug in 1, negative 1, you get 1 half, there's 1 plus c. Did you get c equals negative 1 half? Did anyone get c equals negative 1 half? Nobody?
No.
That's right, that's fine. You solve for c at a different step, okay? We'll pick up with this one on Monday. I only have 2 problems. No, 3 problems for you to try for homework. 1, 2, and 4. 1, 2, and 4.
You guys can have her. I think they're my job. Okay. Do you want to just? Oh yeah, I'll.